Often when somebody's experiencing low energy and a lot of fatigue, it can often be related to anemia. And this is because when we are creating energy, we require a molecule that's very important, that's oxygen. And the big role of red blood cells, of course, is to transport that oxygen throughout the body. So if you are low in oxygen carrying capacity or low in your red blood cells, then of course you're going to experience low energy. Now, what's really important to understand is that, as we all know, like we can be low in iron, which is obviously going to affect the way that we make our red blood cells, and this is going to lead to anemia. Everybody knows this. But there are actually other reasons that can cause anemia as well. And it's not just all about iron. You might be actually getting optimal iron levels from your diet, but in fact still have anemia. So one of these could be that you are eating enough iron, but you're not able to absorb that iron. And that could be because of some issue within your duodenum. I can never say that word. And this is the very first section of our small intestine. This is where we absorb majority of our iron. So if you can imagine there's some issue with, for example, inflammation going on in that area, like our cells have been damaged for some reason, then of course the little transporters that are going to be able to take iron from the lumen of our gastrointestinal system to our cells and then after that to our bloodstream is going to be inefficient or not present at all. What's also very interesting to understand here is that there are other nutrients, like for example B12 and folate, that are equally as important when we are creating our red blood cells properly. Now, what we need to understand about B12 and folate is that when it comes to B12, we actually require another little molecule, a little protein called intrinsic factor in order to properly absorb our B12. So this is released in our stomach. We require this in order to bind onto B12, and this is going to bind onto the receptors within our duodenum and allow us to absorb that B12. So again, if we have issues with our stomach cells that release our intrinsic factor, we're not going to be able to absorb our B12 properly. If we have inflammation in our duodenum, in our small intestine, then we're not going to be able to absorb that B12 properly also. The same goes with folate. We absorb it in the same region of our duodenum, so we need to be able to have a healthy small intestine cells in order to be able to absorb these nutrients. So why is this the case? Well, as we know with iron, when we're making our red blood cells, we require that iron in order to make our hemoglobin. What's really interesting to understand about this iron is that it's going to give us a different reading on our blood work if we are low in iron, like for example, we're not eating enough or we're not able to absorb it. And that's because we use it to make our hemoglobin. So if we are low in iron, our capacity to make this hemoglobin is going to be less, and we're going to end up making these very small red blood cells because there's not enough hemoglobin to basically build them up. And this is called microcytic anemia. So as I said, on blood work, this is going to actually make your red blood cells very small and not many of them, basically. We're going to have a small amount in number. Hematocrit is going to be very low. On the flip side, with things like a B12 and or folate deficiency, either you're not eating enough in your diet, and I need to mention here, B12 you can only find in animal foods. So if, for example, if you're not eating enough animal foods, you're not going to be getting in enough B12. But as I said, there can be absorption issues as well, inflammation in the small intestine, for example. What's interesting about these two nutrients is that we actually require them in the red blood cell production process, but we actually require them in order to maturate our red blood cells. So if we're not getting enough of them, we're not going to mature our red blood cells, and they're going to stay really large. So you're going to have all these red blood cells floating around that are actually bigger than they should be because they haven't matured properly and released out their nucleus. So this is called macrocytic anemia. And like I said, this is really interesting to note what type of red blood cells you're actually getting when it comes to anemia, because if you have very small red blood cells and not very many of them, it's likely that it could be that there's some issue going on with your iron. Whereas if your red blood cells are too large and they haven't matured properly, this could be more of a B12 or folate issue.